Hello, good morning, and welcome to this seminar from Lancaster University and Made Smarter. It's the latest in a series of seminars with the European Regional Development Fund project, GISMO. GISMO is Greater Innovation for Smarter Materials Optimisation. I'm James Stancombe, the project manager for GISMO. And we're delighted to be joined today by a panel of experts from Made Smarter and Lancaster University to discuss how additive manufacturing can transform your business from the bottom line upwards and how to integrate it into your business processes to ensure success. Before we start in earnest, though, there are a couple of housekeeping points. First, please mute your microphones and turn off your camera as we get into the event. If you have any comments on what you see and hear, and if you have any questions from the panel, please add them in the chat box. And my colleague Mark Bowen, who's chairing the panel discussion, will pose them to the panel at the time. Our objectives today are to introduce additive technologies to you using the assets and facilities at Lancaster University as an example, to show you exactly how you can extract those bottom line benefits from the business, from the technology into the business, both at an operational and a strategic level. We'll discuss the key considerations in implementing the technology across the business, and we'll explain the support you can get from both GISMO and Made Smarter in doing so. And of course, we'll also answer your questions. So the format for today, first of all, we'll lead off with a little video presentation that lasts about 15 minutes from my colleagues Armin and Tom at Lancaster University that give the technology perspective on additive. And then we'll move to a longer roundtable discussion chaired by my colleague Mark Bowen from Lancaster that involves Claire Scott and Ian Marshall from Made Smarter and Professors Andrew Kennedy and Alan Rennie from Lancaster, that will look at some of the key issues involved. And we'll take, if you have any comments, as I say, at that point, please put them into the chat and we'll answer your questions during that part of the process. But first of all, we're going to start off with the little video presentation. So it's 14 minutes and we'll catch up with you at the end of that.
Hello everyone, my name is Armin. I'm working as an innovation fellow at Lancaster University. Here I'm working with the companies to analyze the industry problem, find the solutions, and to develop smart materials that improve the existing product. In this presentation, I'm going to talk about additive manufacturing technology, and my colleague Tom is going to show you our capabilities at Lancaster University. So, what is additive manufacturing? Additive manufacturing is a process of joining materials to create an object from computer-aided design, CAD software, or 3D object scanner, usually layer by layer, which is in contrast to traditional manufacturing that often requires machining or other techniques to remove excess material. There are a variety of different additive manufacturing processes such as powder bed fusion, binder jetting, vat polymerization, material extrusion, sheet lamination, directed energy deposition, and material jetting. Later, my colleague Tom is going to show you our equipment for each of these techniques. So, why would I use additive manufacturing? The most important one is to reduce prototyping costs. Modifying a design during a manufacturing in conventional manufacturing can lead to a substantial cost increase or time delays as tools on manufacturing lines are adjusted. Therefore, AM parts are commonly used during a pre-launch activities for a product testing and validating a design. Additive manufacturing solves this problem by moving away from this static design and allowing the engineers to manufacture several iterations of a single design in a cost-effective way. Also, if manufacture requires only few of the same part, it is likely faster to print them. The biggest advantage to additive manufacturing are creating a complex geometries and optimized topology for lightweighting. The more complex object, the faster and cheaper it can be made through additive manufacturing, in comparison to traditional manufacturing method. Functionally graded material, or in short FGMs, represent a class of novel material in which composition or macrostructure gradually change along various directions, resulting in a gradual change in properties and function which can be tailored for enhanced performance. Creating something like this is quite difficult, even with additive manufacturing, and sometimes is impossible to do with a conventional conventional manufacturing method. So, when you use additive manufacturing, there are some challenges. I think the most important one that you need to understand that is AM cannot replace a conventional manufacturing. A lot of SMEs who come to us normally ask us if they can replace a conventional manufacturing with additive manufacturing. And our answer is no. This is simply because traditional manufacturing is still faster and less expensive in long run. Printing out every unit will take longer time. However, complex geometry tailored to particular customer requirement, which may not be achievable with the traditional approaches, can be manufactured with a less material and lower overall cost. The second challenge is the size limitation. In most cases, the maximum available size for printing a polymer is about 1 to 1.5 meter in size, while for metals may only be around 3 to 400 millimeter. Although larger machines are available by using a robotic arm, they will come at a cost. The third challenge is printed objects require post-processing. Many parts that are additively manufactured need some post-processing to clean and smooth out the rough edges. This accounts for 30 to 60% of the overall production process. This is not a major problem when you use additive manufacturing for prototyping. However, as the technology is moving toward the end-to-end manufacturing process, the post-processing becomes the major barrier for having a AM production line. The fourth challenge I can mention is the quality consistency. Additive manufacturing faces a specific challenge to produce a reliable part with a consistent quality, especially in producing a fully dense metal part. For example, using the same print parameters can still lead to a difference in production of the same part. And finally, material availability. 3D printing technology can be used for a wide variety of materials, including metals, ceramic, polymers, and composite. However, there are also limitations as only a relatively small range of material are suitable for such a procedure. So now I'm going to hand over to my colleague Tom Abraham, Senior Engineer at Lancaster University, to show you our capabilities at Lancaster University.
Hello, I'm Tom Abraham. I'm Senior Project Engineer with the Engineering Engagement team, who are primarily concerned with business engagement with the engineering department. So we deal a lot with SMEs, but also with large companies and multinationals. We've been here a long time, we're in our 19th year now, doing this sort of work. Now over those years we've built up quite an extensive range of additive manufacturing equipment. So this area is our FDM suite of machines, predominantly Ultimakers. So we've got Ultimaker 2 Pluses, Ultimaker 2 Plus Extended, we've got an Ultimaker 3 and a couple of Ultimaker 5s. Now they're the workhorses, that's what we generally tend to use more often than anything else, simply because they're easy to use and they're cheap to run. So we do a lot of projects. We do a lot of projects with businesses, but we also do some undergraduate work. We do some work with academics and researchers and do our own research with them. So if we need to build anything larger, still using the same technology, we've acquired 2 machines from a manufacturer called Builder. So we've got the Extreme Pro 2000 here. So that will build up to, well, the build plate's 700 square, up to 1.7 meters tall. So this is obviously a turbine blade, and this is about half the maximum height that we can go to. Okay, so this is our Builder 1500, very similar to the 2000, but a slightly different aspect ratio. So this has got a build bed of 1100 by 500 millimeters with a build height that's slightly shorter but 820 tall. We've also got our suite of reprocessing equipment. So we've got this set of equipment from a company called 3D Evo. So we've got the filament, the polymer shredder to reprocess failed prints, support material, that sort of thing. Then we've got the pellet dryer to dry those pellets. Then we can feed them into this machine to extrude our own filament. So not just reprocessing of existing materials, but we can also start playing around with new materials, putting additives in, that sort of thing, to make our own specialist filament. Okay, so this section is our resin machines. So here we've got several machines from a company called Photocentric, who specialise in what's called DPP, so daylight polymer processing. So it takes a photoreactive resin, shines a light on it, where the light hits it, the resin hardens. We've got the large machine here, which is the Magna, that's got quite a large build volume, about 500 by 400 by 300 build volume. Then we've got a couple of smaller machines. We've got the HR2, that's probably about A5 size by about 200 or 300 tall. And then we've got a smaller machine that's around A6, but more precise. So if we want to do smaller but higher quality models, we can do on the LC Precision. We've also got a Form 2, and we're in the process of acquiring a couple of Form 3s as well. Okay, so this is our Stratasys J750, which is a polyjet machine, which again uses a UV curing resin and jets it out of ostensibly inkjet heads here, and there's 6 material heads and 2 support material heads. Sprays it onto this bed that's about 450 by 300 by 300. I can't remember the exact build area, but so what this will allow us to do is do full colour prints, similar to your inkjet printer, where it blends the different coloured materials, but it will build it up in layers, so you get a full colour 3D print. It will also allow us to mix different resins, so we've got an ABS mimic and various other ones, flexible mimics, and you can blend those to tailor the properties of whatever you're building infinitely effectively throughout the part. So you can go from a fully rigid material at one end to a fully flexible material at the other end, and blend that through the part, so every single node can have a different blend of materials. Almost impossible to do with any other process, certainly conventional. So we're in a different lab now, but this is our powder material processing area. So here we've got 2 metal 3D printers. So this one is Realizer 100, and this uses metal powders and a fibre laser to melt the powder together in individual layers, typically around 50 microns, to form a solid part that's almost 100% dense. The machine next to it is our newest acquisition. This is the Meltio 450. Now this uses a combination of wire extrusion and metal powder spraying. So we can have multi-material extrusion, so we can blend different materials together, and also spray various materials from a hopper with the air feed, the argon feed. Okay, so this is the 3D Systems S-Pro 60. Now this processes polymer powders, typically nylon 11, nylon 12, but there's also flexible powders. There's investment casting powders that you can put in. You can put glass fill powders and various other things. Spreads a layer of powder, uses a CO2 laser to sinter that powder together. And this exactly the same process, but on a smaller scale, is the LISA by a company called Sinterit. We're in the process of getting 2 of the latest iterations of the LISAs. Does the same job as that, but because it's smaller, it's easier to turn the machine around to reprocess the powders, to sieve them and everything else, unload the machine, but obviously not as big a build volume, not as powerful a laser. The last machine is the SolidScape Z Studio in the corner. Now that's quite a specialist machine. That will only print in wax, and it's specifically designed for investment casting. Very, very precise. It's by far our most accurate machine and most precise machine, with layers going down to around 6 microns.
Thanks for that, Tom. So now I'm going to give you a little bit more information about how Lancaster University can help you. With the GISMO project, we can help you to investigate the additive manufacturing technique for the first time, establish your own in-house capabilities, prove a new concept design, product or process, overcome a problematic design or material issues, increase your existing materials palette or capabilities and capacity, and understand the latest thinking and techniques. If you want any more information or you want to discuss your ideas with us, please get in touch. Thank you so much.
Well, what I'd like to do now is move on to the next stage of the seminar, which is a panel discussion to sort of expand on those and some of the ways, both from the technology point of view and the business perspective. I'm delighted to welcome our panel now to do just that. And if you've got any questions for them or any views on what they're saying or any questions about what you just heard in the presentation from Armin and Tom, please do drop them into the chat and we'll make sure that we get them answered. Now, you don't just have to rely on these mug shots in front of you. We're actually going to ask the panel members now to turn on their cameras, and I'll hand over now to my colleague Mark Bowen to take us into that next phase of the seminar. Thank you.
Well, thank you very much, James, and good morning to all who are joining us today on this, well, here in Lancashire, bright sunny day. This session, or this part of the seminar, is scheduled to last for about 60 minutes. So please, as James says, think about the questions. This is a great opportunity to ask some real experts in the field, both from a business perspective and from an academic and sort of operational perspective as well. To start things off, could I ask each of the panel members, and Ian, just because you happen to be at the top left of my screen, I'm going to start with you, just to briefly introduce yourselves and say something about the key points about the implementation of additive manufacturing that you'd like to get across to the audience today. So, Ian, the floor is yours.
Thanks for that, Mark. Yeah, good morning, everyone. I'm Ian Marshall. I'm one of the team at Made Smarter, one of Claire's colleagues. I'm known as, my job role is Digital Transformation Specialist. And essentially I'm working with businesses to try and get them to understand the wider benefits of digital technology adoption. And one of those, of course, is additive manufacturing. I would say one of the key points I would like to make is there are, well, we're talking about 2 great programs here today, GISMO and Made Smarter. They're widely available. They're fully funded for businesses, And my general advice and point I would like to make is really make the most of them, because they are independent and impartial. And it's really going to help SME businesses understand the benefits of this technology, how best they can adopt it, and how they can do it in a structured way. So that would be what I would like to get across.
Well, that's great. Thank you very much, Ian. Andrew, if you could follow up next, please.
I'm Andrew Kennedy from Lancaster. This is my actual face. It's not some sort of superimposed face. My expertise is in advanced manufacturing. So I have a research group that looks all across a wide range of different aspects of manufacturing, including additive manufacturing, but also extending to casting and joining and powder metallurgy as well. So I have broad interest in a lot of different research areas. I'm supporting this activity within GISMO, which is in the additive manufacturing field. So happy to talk later about answering questions about processes, particularly keen on the metal-based processes. Also, one of my research areas of expertise is in porous materials, whether that's for energy storage or biomaterials or sound absorption, fluid flow, that sort of stuff.
Thank you, Andrew. That's great. Continuing to go clockwise according to my screen, Victoria from the Growth Company.
Hi, it's Claire from.
Oh, sorry.
It's all right.
I'm
We
not doing
do
very
have
well
two.
Not doing very well as chair, am I? Good grief.
We have two Claires in the Growth Company, so we have to differentiate between by using my middle name. So now I'm from Made Smarter. I'm the Industrial Digital Technology Advisor, and my specialism is in additive manufacturing. So I've come from the aerospace industry, where I was at the Centre of Excellence for Additive down at Filton. And I've come on board to help SMEs understand and adopt AM. And one of the things that I would like people to really focus on today is why you would want to use additive manufacturing. I want to make sure that people understand the technology, but also understand the application, the correct application of the technology.
That's great. Thank you very much, Claire. And last but certainly not least, somebody who I definitely do know and whose name I won't get confused. Good morning, Alan.
Good morning, Mark. I'm glad you remember my name. We only had a last conversation yesterday in the afternoon. So good morning, everyone that's attending. My name's Alan Rennie. I'm a professor of manufacturing engineering within the engineering department at Lancaster. Also a contributor to the GISMO project, and like Andrew and other colleagues, supporting researchers, so PhD students that are also available through this programme to support work with the SMEs. My background is additive. I first started in additive manufacturing in 1995, so quite a while ago now, and people don't appreciate how old the technology actually is and how long it's been around. And back then, 95, I was part of one of the, helped set up one of the first SMEs in this area. So it was a bureau service provision that was established in the south of England. A bit of a generalist really with additive at Lancaster over those years. One of the only people that was involved with the technology. So I was spreading myself rather thin, and it's great that at Lancaster now we've got a good critical mass of capability in a lot of the areas that Andrew highlighted as well. My real interest now is trying to focus towards design and applications, and Claire mentioned that she'd be keen to focus on that as the session goes on. And really how those applications come out from businesses, whether they're SMEs or larger organisations, and therefore the right technology choice so that we can take those things forward. Recently launched, if it's of interest to people that are attending, the EPSRC supported Design for Additive Manufacturing Network with colleagues at Loughborough University. So again, big focus there on particularly on how design and the use of design can help influence the use of additive manufacturing, be that in materials, be that in functionality, things like that. So keen to talk about that as well later this morning. Thanks, Mark.
That's great. Thank you very much, Alan. Okay, ladies and gentlemen, the next part of the seminar deals with a number of set questions to the panel, and each panel member will have a lead role in answering the question, but then other panel members will be joining in. But for the wider audience, please think about some of the things that you hear and think about the questions that you want to ask built on the responses that you hear. Ian, again, I'm going to start with you. I'm not picking on you. It's just you happen to be the right person for this. And really, we're thinking about the strategy from a business point of view. Why would a business consider even adopting additive manufacturing?
Yeah, and I think yeah, it's a good question, and I suppose in a wider sense, all businesses, in any case, it's good business practice to be constantly reviewing what their goals and objectives are, and how, and in terms of the technology side and industrial digital tech, what we're trying to do is assist businesses with the exploration and adoption of those. So in terms of looking at the long-term goals, we can then say, how might additive manufacturing add to what they're actually doing? And this will really very much be a key message of diversification. Is there a better way of doing things? Can they explore a better way of doing things? I would like to just, and I'm sorry to kind of mention the C word today, but COVID. And I think if there's been one silver lining to this, from our perspective, to this pandemic, it's been the fact that businesses have taken a little bit of a step back, and in some cases been forced to do so, and really think about being a lot more strategic and really consider their options. And I think that's been quite a major benefit. We've been able to help them. One of the areas that we can help with is we look at developing it's quite a holistic view of the business through a workshop. But this really does help businesses. This is fully funded by Made Smarter. It helps them explore all these new potential routes to market, how they can even start looking at, well, considering additive in an R&D capacity. They've never really done that before, but there's potential to do that in-house. And then clearly they have the expertise on hand from people like Claire, thankfully, who can help them start adopting that. So yeah, and I think it's just that wider strategic way of focusing on maybe diversification and how this technology can actually benefit.
That's great, thank you, Ian. Claire, segued very nicely from Ian, as I noticed you've got your hand up to add something.
I was just going to say, I mean, just picking up on Ian's point about the COVID, it's also the agility, the ability to give the agility to a business to respond to situations like COVID, really, and that's one of the reasons you'd want to adopt additive.
Yeah, as a more on the business side than engineering side, is there a significant cost involved in investing into additive manufacturing, or are there, other routes where you could potentially use other existing, I'm going to say printers for my lack of the vernacular?
It's a really good way of describing them, but just picking up in terms of the cost barrier is very depending on the application, of course, but it can be as little as £300 to get a consumer unit, and for an SME to then use that in a product development, and then be able to develop a new product, and which will then be manufactured using a different technique. And we do have examples of that within the Made Smarter program, where I've gone into a business where they bought saw it on a special buy in Aldi, and they went, okay, this may be something to have a little look at, and had someone who's really keen to learn how to use the technology, and they ended up finding so many other use cases that they come back to then invest more in the technology.
Wow, that's fantastic.
And they also won a contract based on the product that they designed.
Well, I think that's real testimony. I mean, as I say, as a non-specialist in this field, I'm quite amazed that you can get your first experience of additive manufacturing for such a low cost base. Alan, you've got your hand up.
Yeah, I think just following up, it probably gives us the opportunity to answer one of the first questions that are in the chat as well. That's from Neil Burns around practice builds, and Claire's already said, you know, £200 or £300. If you looked on Amazon this morning, you probably find some machines on there that are a couple of £100 and maybe £15 for a kilogram spool of material or something like that, but all the way up to a couple of million really for some of the more industrial, higher level, better production machines that are out there. So the comparability, I think that Neil was talking about in terms of results there would vary hugely. That £200 or £300 that you're going to spend, you're going to get a rough and ready prototype model, something like that. But actually, if you want to go into production and have a fully QA'd manufacturing system or process in place, then you're looking really at high-end investment.
Sure.
So the results, there might be some comparability there. Really good for what was originally, you know, 1995 when I started rapid prototyping, you know, and it's evolved through its names now to additive manufacturing. It's a mindset there, though. The terminology really is a mindset. You're using the additive manufacturing technology to either rapid prototype, rapid manufacture, or rapid tool generally. So it's a good question.
Okay, great stuff. Thank you for picking up on that, Alan. And just before we sort of end on this first question, what about the actual skills required? So would a firm who's not used it before find that it's a relatively simple thing to gain initial experience with, or would they need to get a lot of training? That's an open question to the panel.
Alan?
I don't mind because it is a bit of a bugbear of mine actually. And when you think about it, you wouldn't buy a high-end expensive vehicle without having a driving license first. And unfortunately, there's a lot of people who go out and they buy the low-cost machines, the desktop machines, for a few £100s, and then they think, how am I going to design components for this? The design in terms of the skill, you know, you need to be able to design generally if you're going to be using these technologies. And whether that's you know, one of the easier to learn computer-aided design packages, or you go full on into the high-end design and modelling activity. There's a lot of work around that just now as well, in terms of looking at heat transfer and finite element modelling and those sort of things as well, to really design good components. So skills are essential. Yeah.
Sure, and I guess that you know, from all aspects, this is where both the growth company and the university are well situated to help, particularly through GISMO, to provide that expertise and advice and the training, and potentially even some funding to get started, I guess. Okay, right. So the next question is Claire. I'm going to target this one at you, and really thinking about the perfect scenario. Okay, when is it right, and perhaps more importantly, when is it wrong to use additive manufacturing? Thinking, you know, from a business perspective.
So I think I'd probably split it into three sort of use cases, and there are probably a lot more, but really, if you design your own products, you can make use of additive manufacturing. So we can do it in the prototyping stage, as we mentioned, and then then move on to manufacturing using a different technology. If you do manufacture in with a different technology, machining, for example, if you have high tooling costs or a long lead time on the tooling costs, that would be another good scenario to adopt additive manufacturing, because you can have potentially on-demand tooling. But also then, if you wanted to shorten your life cycle to the final product, and an example of this, I think, would be in the film industry. A company called Leica used, in fact, the J750, which I think you've got there at Lancaster, to print faces for stop motion animation, and they can print an entire scene in a build and then have it ready the next day to actually go on and film the scene, which for a stop motion animation feature dramatically reduces the amount of time it takes to actually complete the filming of that. So it's those are some really good examples, I feel, that would be kind of perfect scenarios.
Okay, and take the opposite, because I guess, like a lot of things, businesses are subject to trends and the pressures of customers expecting businesses to adopt the latest trends. There's going to be a time or a situation, a scenario, when it's not the right thing to do. So what can you say about that?
When is it not the right time is if you're trying to make the same product that you're currently manufacturing faster with a printer. It's not going to work. If you're just trying to replicate and switch out the technology, the manufacturing technology, that's not gonna work, because you need, it's a workflow for a start. You need to start from the design, and this is just one element. So I guess that's when it would be wrong. And just think again, it's just having probably the mindset thinking, oh, I can build anything. I think that was one of the big taglines that Additive had. If you can think about it, you can make it. And within 6 months of working in Additive, I discovered that's actually really not the case, and you just end up having the understanding that it is a tool in the engineer's toolbox to manufacture a product, and if you can't make it any other way, well, Additive might be a good opportunity.
But innovation, really taking the eye out of GISMO, innovation is the real driver for adopting additive manufacturing. I saw something just a few days ago, a farming program, and it was looking at a county show somewhere. I'm sorry, there is a purpose to this. And the presenter was talking to somebody from the NFU, the National Farmers Union, and he was stood next to a large piece of farm machinery, typically for ploughing and seeding arable lands. And he was making the point that farming is very innovative, and it's at the cutting edge of technology and research. And he pointed to this machine and said, this was printed. And I thought, my life, that must have taken forever. And I wonder how the cost stacked up. So perhaps, there are blindingly obvious examples of people just jumping on the bandwagon for the sake of it. But actually, it's not the right thing or the right time. Andrew, I noticed you've got your hand up.
Yes, thanks. It's just a quick point, really, to follow up from Claire. I think there's a growing body of experts and expertise that can give people a very comprehensive evaluation of whether an AM approach is suitable, from a life cycle analysis, from analysing productivity and the concept of reduced waste and balancing all of those elements. So I think there's a lot of people that people wanting to get into it can now go to chat about, to see whether the economics stacks up across the whole spectrum of the product in its life.
Thank you, Andrew. That's a really, really interesting point, which would have allowed me to segue seamlessly into the next question. But I note that Ian's got his hand up, so I'm sure he's got a really important point. Ian.
Yeah, I just wanted to add really to the couple of points that have been made. And I think looking at perhaps when it's the wrong time, we've already demonstrated that you can actually move quite slowly and have some quick wins. I think sometimes businesses feel they've got to make a grand gesture, and it could be quite expensive to adopt. In other words, take a risk. And I think it's very important that you actually do this in baby steps. and really consider all your options very, very carefully, and do it very much as an R&D project before kind of diving in to something that you're not really that comfortable with.
Yeah, that sounds like eminent common sense, Ian, and that's obviously stimulated some more thought and comments here. I'll go to Claire first, because it's just beat you to the hand, Alan.
So I was just going to reiterate, it all comes back to culture and why are you looking to adopt additive manufacturing? Focus on the reasons why and make sure that you understand the business case.
Okay, thank you. Alan?
It's a prompt from what Ian had just said. You know, we do run periodically undergraduate and postgraduate student projects, so there is resource there, and if you do want to try out something without any real commitment, you know, we have labs, we have facilities available, then get in touch, you know, and either through GISMO or one of our other programs for those that aren't from the Cheshire and Warrington area. There may be some support available somewhere.
Yeah,
so
I think
just drop us a note.
That's a fantastic offer, Alan. Thank you very much. And of course, that's what the university is about. It's about using our facilities and the expertise that we have to benefit the wider community. So what we're going to do now is just move on to how we unlock the wider benefits. And that's why I said, from what Andrew had already said, it would have been a nice segue. You know, thinking about things in the round, thinking about all of the elements, about energy saving, about waste reduction, etc. So thinking about unlocking all of the benefits and the bottom line benefits. Ian, I'm going to turn to you again as a business advisor or business specialist. What would you say about that?
Yeah, and I think overall, if a business looks at this opportunity quite carefully, it gives them the opportunity to actually save money across the board, really, at the same time as actually becoming more innovative. And it can be even in areas like you know, unlocking the design freedom where they may be currently restrained and shorten lead times, but it can then also help them think about things. I think I've referred to this before, but I think it's worthwhile making the point again, is looking at things very much in an R&D sense, so they can actually think about planning it and structuring it in such a way that it's not impacting too much on the current operation, and testing it in the right way. And I think if it's kind of done in that way, in a structured approach, I think it's really going to add long-term benefits. And again, just to reiterate, not to really move too fast, and not to make, you know, too high level an investment that you're not really going to be able to show the benefits of for quite some considerable time. So all those areas, I would say.
Okay, thank you very much. Alan, I'm not sure, is that a legacy hand or? Yes, it was. Okay, we're all guilty of that and talking when we're muted, I know. So does any or any of the other panelists have thoughts about the long-term benefits, or, you know, the benefits that perhaps we might not think about when we're initially considering going down the route of additive manufacturing? We've just done that one to death, have we? Okay, not a problem, not a problem. Okay, it is a major step, particularly as Alan mentioned. You know, we can start with a £300 machine from Aldi, but it can go up to several millions of pounds if you're going to make a serious investment and a potential change of direction. So what are the key considerations when we're actually thinking about starting to use additive manufacturing, and, you know, what changes need to be made? Ian, you're going to think I've got a vendetta against you, but it seems right to ask you initially because of your key role, and then possibly come to Claire. So Ian, if you could start the ball rolling, please.
Yeah, sure. Yeah, I mean, I suppose again, one of the first impacts is really how additive manufacturing is actually potentially going to integrate or impact with the current operations. I think that's very important that businesses are aware of that and how that what the long-term impact will be, and again, are they in a position to invest, and if so, do they actually have an available budget? And again, it's a link back to really what Claire said earlier as to why additive is under consideration. I would like to say, though, from a Made Smarter perspective, what we do help a business to do is consider additive as a blend of a number of technologies by really running a workshop session with them. And really that looks at the business as a whole. We're not focusing on the technology as such, but we look at the 4 key areas, which is the product, the process, the people in the business, and the service, and how they deliver that. And out of that, the objective really is to really make a series of recommendations as a start point as to the technologies that they will maybe wish to adopt, and listening to how they currently do things, and making sure that we're doing this in a structured way. So building that case, if you like, for digital technology adoption and clearly additive manufacturing.
Thank you, Ian. Claire.
I was going to build on that, and one of the good things about these workshops is the fact that you get the opportunity to identify what are the challenges within your business, and that's the key. I think there are some of the businesses that we see have an opinion on what their challenges are, but when they go through these workshops, they find out, well, hang on a minute, there's much more pressing challenge here. So it comes back to the why, and how is additive manufacturing going to actually solve those challenges? Remember, it's a tool in the toolbox to fix something.
I think that's a really important point. It is not a panacea to solve a business's problems across the board. It's sorry, a pun. It's an additive. It's an addition to the strength of the company, and that takes us on really to the next point. There are, of course, with anything, and particularly any relatively new, despite Alan being involved since 1995. In fact, I think he was involved when Noah was around, and the first art was partly developed by Alan and using additive manufacturing. But there are pitfalls potentially for the unwary. And certainly I would imagine this is where both the growth company through Made Smarter and advisors such as Ian and Claire, and through the university can help avoid those. But to really sort of think about, get people thinking about them, what in your experience, and Alan, I'm going to direct this at you initially for a change, give Ian a rest. What are some of the typical pitfalls that you've seen?
So just to start, it wasn't the Ark and it wasn't Noah. I think it was probably the Egyptians and the layered manufacture of the pyramids. Just something different. Some of the challenges and some of the pitfalls, really. I think I'll give you four things that you'd really need to think about there. And some of these we've already discussed really in part as we've been through some of the questions so far. But really, it's choosing the most appropriate technology, or additive manufacturing technology type for the needs of your business or the product that you're trying to bring to market. If you refer back to the little presentation that Armin had played or put together for us at the start of the session, there's 7 basic technology types there, all the way from vat photopolymerization, for example, using liquid resins, to powder bed fusion, etc. And really, you've got to understand what materials you need and therefore what type of parts and the production rates and all the other things that we've discussed so far as well. Claire's mentioned, volume and complexity, etc. So it's getting the right technology, and really you've got to have an understanding there. Engage with people, talk and learn. So get some education around it. I think that then moves on to design. So we're moving away from conventional, what we consider as conventional manufacturing technologies, so your subtractives and your formatives, and really how do they differ from additive? And that's where we now have the concept. Instead of design for manufacture, we've got design for additive manufacture. So another plug there for our EPSRC network. Segue again, as you're referring to. But it becomes a bit more complex there, because it's not just design for additive manufacture, it's the individual processes themselves. So selective laser sintering or the powder bed fusion, as an example, there's no need for support structures. Compare that to SLM or your material extrusion, so the FDM technologies, you need support structures. So you've really got to think about, again, the design of the component and how you might orientate that, and where support structures will feature, and how do you remove them, and post-processing, all those other things that mean there's extra equipment and resource and facilities that you need to have within your company to deal with that. The third one then is materials. And like I say, feeding into things like finishing and post-processing, you are going to get rough and ready components, particularly if you're going low budget. So you're going to get what we call stair stepping. So that's the you can see the individual layers. So if you have something oriented at an angle, you'd get these layers. Again, my pyramids example there, you can see the individual layers, if you will, on those. And therefore it's about integrating other technologies into that. So do you overbuild, add in some extra that you might consider a tolerance, and then you machine that back as an example. So post-processing, tumbling and polishing as well to try and get a more optimized component for whatever you need. The final thing then, I think, as a pitfall or something that people have to consider is although you might be able to print something or additive manufacture something, should you? Because it might not be the best use of the technology. And just because you can print it and you think it's great to do, and it's people say that buy this for this extra value because I 3D printed it. There might be another way that's more cost effective, less time, more environmentally friendly, use a different set of skills, things like that. So those are the things I think people would think about, and pitfalls and mistakes that might be around.
Fools rush in where angels fear to tread. Andrew, I noticed you've got a hand up.
Yeah. I mean, I just wanted to add to really what Alan was saying. I think the other issue or consideration is everything else keeping a pace with the innovations in AM? So you can build stuff, but can you inspect it? Can you measure it? Are there the appropriate testing standards out there to ensure that what you're manufacturing fits to the standards that are appropriate for AM parts? If you make something, can you join it? If you make a metal AM part and you want to bolt it onto something or weld it to something, new techniques need to be developed. It's not necessarily treat it as you would anything else. So it's all the peripheral stuff needs to keep a pace, and you need to be abreast of the fact that you might need to do things differently if you've got an AM part.
Good point. Claire?
Just to build on that, and as an example, I think it's also for the suppliers, when they're saying, oh, you can laticize everything and that will reduce the weight. And we had a supplier in my old job who says, oh, but this is brilliant, we can generatively design something. And we had an example bracket which was traditionally manufactured, topology optimized, so the weight was taken out, and then we also put a concept bracket together which had lattice involved, and the chief engineer threw away and ignored the latticized bracket, because how on earth do you NDT a lattice for aerospace? You can't inspect that kind of bracket, and preferred just the topology optimized one. And some suppliers didn't get didn't understand the customer was saying, and was hammering on, but you can create lattice,
Yeah, so it's an interesting point that I think I briefly touched on earlier. There is the customer sometimes can be blinded by the market trends, and in fact, it's you know, the good old steady way is perhaps the best in some situations. Ian.
Yes, indeed. So yeah, I just wanted to add a couple of things with recent cases that I've experienced with some of the pitfalls. We've had some situations where, again, we've been running a workshop session, but a business has initially made contact with us directly. Their real interest is about the adoption of AM kit. They've seen some bright, shiny new equipment that they think will solve all their problems in terms of manufacturing and help them to diversify. And often the case will demonstrate in the workshop that really it's not that equipment that they need right now, because that could really cause problems further down the track. What they really need to consider is maybe their systems and processes in advance of that. And often the client businesses have almost answered their own questions, so that's where the workshop has really been a major benefit for them. And yeah, generally, if they're determined they're going to go out and buy this equipment, we can't stop them doing that. But I think that's another way that that could be a pitfall if they actually went in, invested, and then maybe caused a negative impact on the business.
Yeah, I think that's absolutely valid points from all the panelists there. So yeah, okay, not the panacea. There are problems, there are pitfalls for businesses, but that's why we're talking today, and that's what we're here for, to help address these questions and avoid these pitfalls. Moving on to the next, almost at the end of the formal questions, but the penultimate one. Time and tide, as they say, waits for no man, and technologies are advancing exponentially, whether it be computing powered, data science, or in this case, additive manufacturing. So I'd like to direct this firstly to yourself, Andrew, if I may. Emerging developments in the field of AM. What do you see as, the future in terms of technologies, materials, and applications?
Yeah, so I mean, there are large numbers of research groups in industry and academia pushing, huge advancements across all sorts of different areas. I thought I'd highlight a few. So there are people looking at new structures. So looking at porous and lattice structures and all sorts of complicated, weird and wonderful mathematical expressions of novel structures, and also things like meta materials and 4D materials, all sorts of fancy buzzwords about materials that transform in service or vary with time or have entirely unique properties that traditionally manufactured materials can't have. And many of these are still very much lab-based. It's the guilty secrets of universities chomping away doing all this stuff, perhaps not with obvious applications in mind, but there's some very clever and interesting stuff happening around the novel structures that AM processes enable you to have. I think there's also a lot in materials as well. So in composite materials, polymer composites, also polymer-based systems with additives. And of course, everybody goes on the trend of chucking in carbon nanotubes or graphene or anything else that they can find on the shopping list of exciting stuff to pile into their polymers to enhance properties or whatever it might be. I think ceramics, people are still trying to push printing with ceramics. There are some technologies out there. Some of them are good, some of them are not. I still think there's a market for it, but it's still really at its infancy. There's good work in designing new metal-based systems. I think from a metallurgist perspective, I think AM approach initially was pretty lazy. You say, the aircraft industry used 7000 series alloy. Let's print in a 7000 series alloy because they do it. I think more and more people are designing alloys specifically for AM. So not just taking off the shelf established alloys, but making sure that they're designing ones that are fit for purpose. And there's a lot of good work in that area, and that area is definitely increasing. And then lastly, I think in processes, there's lots of new machines that are coming out, and a lot of development of new processes that are lower cost metals. So going away from processes that involve heat effectively to use filament printing, and then you can go and sinter them in traditional equipment that's used in the powder metallurgy industry. So you could do it in batch processes, and you can get your costs down, although there are some issues with binders and stuff. Hybrid processes that we're looking at that combine wire and powder, that give advantages of high build rates, switching over from materials within the process, and then just larger builds, faster builds, higher resolution builds, and people looking at, including ourselves, looking at in-process monitoring and control from a perspective of not only quality, but also from managing or stopping builds that are going wrong. Nobody wants to wait 24 hours to receive a build that's twisted like a banana. You would rather be able to see that it's all going wrong after a couple of hours and scrap it and start again. Ideally, you'd like to auto-correct within the process, but that's still quite a tricky thing that is an objective rather than a realistic goal. And then finally, applications-wise, well, I don't even know where to start. It's limited really to your imagination, I think. From my own perspective, I see people coming to me talking about printing porous materials for battery technology, biomaterials, but I only really look at one end of it. It's limited really by your imagination, and I guess by all the other stuff that follows through. Like I was saying, like inspection and metrology and qualification and testing. So you can think of the applications faster than perhaps the rest of the technology can follow it to make sure that what you're doing is actually going to be, is actually going to bear fruit.
Yeah, I think everything you say, Andrew, is absolutely valid. I was introduced to Victrex, as you know, probably about 3 years ago, and I live only about 3 miles from them, as it happens. And they conquered aerospace with the polymers and printing, and they more or less conquered the automotive industry. But the next big thing for them, which blew me away, and I don't know why it should, because it was so blindingly obvious, really, was medical applications. And I've got a titanium knee. And they said, well, if you'd waited a few years, you could have had, one of ours, and it would be lighter, more durable, which is great, and it's less likely to be rejected by the human body. And then they showed me jaw bones and teeth for facial reconfiguration after accidents or cancer and stuff like that. And I thought then, this really is the science of tomorrow, and you are only limited, as you say, by your imagination and some practicalities, but, that will change with time. Sorry, I'm rambling on there as the chair. That's not my role.
Well, I think that was a very good point, Mark. I mean, PEEK is really one of those materials that pulls in all directions. It's a challenge because it falls between regular polymers and metals in terms of temperatures, which means that none of the processes are really suitable. So processes are being changed to accommodate PEEK. And from a material perspective, not only are they trying to put in additives to make them more bioactive, but also they're looking to change the PEEK compositions to try and lower the melting point so that you can use it on more regular machines. So that application around porous biomaterials within PEEK is pulling in all directions, from process, materials, structures, everything.
Yeah, fascinating. Any other panelists would like to add anything to that, looking to the future? And it really is, it's a bit of swag, but, this is a forum for that. Let's stimulate some discussion.
I think, come back to design again, Mark, design being more intuitive as well. And Claire talked about topology optimization earlier as well. And we see that in terms of being able to create products. Additive manufacturing itself, complexity doesn't cost any more, and it might do so in more conventional processes. So irrespective of how complex you make that, there will be an additive way that you can take a design for a product forward. So having more intuitive design software, unfortunately, probably, I might be wrong in saying this, but it dumbs down the need for a good engineering education and background, because the software is doing it for you.
Right.
So, but Easy CAD or some of these other things that come out that anybody can do it with the £200 or £300 printer then in the bedroom, because they're just pushing and pulling on a geometry on the screen, and then they hit print from there. But I think that's a good thing. There are more complex and different ways that design can impact on the way that you are actually conceiving, conceptualizing products, and topology optimization and new packages like N-topology and stuff that comes out of additive flow. All those things for different applications of additive really does help, I think, in streamlining that pre-manufacture stage, so that you know that your product's going to be right before you commit to the build, commit to fabricate. Yep.
That's great. Ian, you had your hand up fractionally ahead of Claire. Ian, you're just muted at the moment.
I'm muted, oh yeah.
Yeah.
I'm just about to say that I made a change, Claire. It was probably more rather than a comment on immersion development, probably a question for Andrew, actually, because I'm interested in the development around ceramics, because I've had a client come to me, and obviously we don't name names, but the question was really around about the potential to develop this for short-term runs, but looking at really for the leisure sector and the commercial sort of bathroom and hotel bathrooms, and really focusing on quite innovative designs. So they weren't going to be huge production runs, but they were having kind of issues saying, is this technology ever going to be possible? And because the limitations they face now are not really worth them going into this long term. So any thoughts on that, Andrew, and where that might be?
Yeah, I mean, I think even more closely than for polymer or metal parts, you need to look at the business case for ceramics, particularly for things like bathware, sanitary ware type of products. I think the sums really just don't add up at the moment. The machines themselves do offer some flexibility, but they are still dependent on a lot of post-processing of drying and sintering, which you still got to get back into the mainstream processing of ceramics to develop those final parts. So I think you have to be looking at high-end, high-value products for this to be anywhere near worthwhile. So yeah, I mean, it's another of those things you've got to look very, very closely for the cases. Somebody's Armin, the innovation fellow, has posted in the chat. Form Labs and some other companies do have machines that do build sort of ceramic parts or pseudo ceramic parts, so ceramics and binders, and they're people extruding clay and all sorts of other things. But at the moment they're playthings. The business models for them are don't necessarily show them to be worthwhile for fancy taps or a nice looking sink, not unless you're a Russian oligarch and you want it gold plated afterwards.
Do you know something that we don't, Andrew? Have you been on holiday recently? Claire?
No, I can't afford the £1,000 to come back.
Claire, you did have your hand up.
Sorry, I was just about to cough.
Yeah.
So looking to the future, I think sustainability and actually additive manufacturing proving its green credentials is probably one of the big things. And I think a study just came out saying that people are touting the green credentials of metallic additive manufacturing, but when you look at it as an entire life cycle, it's not really that green, and in fact perhaps even worse. So I think that's one aspect that's going to be coming more to the fore very soon. But also from an SME perspective, the technology that's costing millions today, in 5-10 years time, is that going to be the same as an FDM machine today? the cost will decrease and become a lot more accessible.
I think that's really interesting. So, have I interrupted you, Claire? I'm sorry.
No. Although I was going to highlight I think it was highlighted in the video. One SLS machine took up half the room, and then it's the Lisa Pro is there on the desktop. Smaller build chamber, but same technology.
Right.
So I think that's going to be another trend.
And I think this is just sort of flagging up something else that Lancaster are leading on. There is a project that works across the Northwest that includes Warrington and Cheshire, working in conjunction with other universities out of our environmental centre called EcoI Northwest, which again is an ESIF European funded program that can actually, for example, look at the benefits of going down the route of additive manufacturing versus conventional in terms of sustainability, the cost benefit analysis, and being able to prove your green and carbon reduction credentials. So that's something that can, be considered as well before making a real step change. So I'd add that one. I know that everyone's getting tired of listening to me witter on. So I've got one last question to pose to the four panelists. So I'd like you all to answer. I'm sure you will. I'll start with my colleague Ian, again, top left. If you could give one piece of advice to a business thinking about additive manufacturing, what would that piece of advice be? Your golden nugget.
I think it would be, don't be afraid to seek advice. I think go out there. These programs are available for businesses to help them make informed decisions. And really that's what it's about, being independent and impartial. Seek that advice, seek that expertise, and I think you might be surprised at the amount of help that's available to you.
Thank you. Very succinct. Andrew.
I just kept mine to don't panic.
Yeah, I noticed in the chat. Yeah.
Yeah. I think it is quite daunting as a newcomer coming into all the technologies, all the different materials, how the different processes stack up. I think Neil posted a question about can you practice in plastic and see whether that's going to give you the same results in metals. I mean, the short answer to that is no. I think it's the difficulty is you've got to get stuck in, and it can seem like quite a complex and difficult journey getting to the right material, the right process, the optimized processing conditions, and all sorts. But there are people there to help you. And GISMO, of course, with a GISMO touting hat on, is a source of free help and support, for those who are obviously eligible. Otherwise, we provide a good service at a cost-effective price.
Good plug. I like that. And Alan, thank you, Andrew.
So I mean, I'm in a lot of networks and journals and the national conference in the UK and things like that. So I know quite a lot of the people in the additive world, and I think really everybody's friendly. So go and speak to them, talk to them, and learn from them. Nobody's going to turn you away. And internationally as well, some of the most international leading researchers that are out there will talk to you. They'll give you some of the time if they can. So really, if you're starting out and you want to get to know how to do something or who to speak to, come to people, talk to them, and educate yourself that way. And then following on from Andrew, GISMO is an excellent opportunity to do that.
Yeah, that's a great piece of advice. Absolutely, and certainly not least, Claire.
So I would say register on the Made Smarter website, www.madesmarter.uk, since we're all plugging. But find it's got to be reflected what other people have said. Find a partner to work with will help you help you grow with the technology.
That's great. Panel, thank you so much for making my life easy. Your responses were full and, I think, as a non-specialist, very, very down-to-earth, pragmatic and understandable. I'm sure that the audience have got other things they'd like to ask of you, but can I just say that there is so much information in the chat which will be available. Just a personal thanks again, and I'll hand back over now to James. Thank you very much indeed.
Thanks so much, Mark, and thanks to Claire, Ian, Andrew, and Alan for, as Mark said, a really stimulating and informative discussion. And I've learned so much. Never mind from all of the resources that are appearing in the chat, like the Design for Additive Manufacturing network. But I now know what stair stepping is, which is a new one for me, and I also now know to take a closer look at the bargain bin at Aldi. So lots of stuff has been learned today. So thank you so much to the panel. And if you do have any remaining questions for them, let's please do put them in the chat. Or if you're watching this seminar after the event, as it were, please do get in touch with us at GISMO by emailing gizmo@lancaster.ac.uk. But moving on from the panel discussion now, I think what we'd like to do is just focus on the ways that both the Made Smarter and GISMO programs can help you. And perhaps, Ian, you could say a word or two about it from a Made Smarter perspective.
Sure, that's fine, James, thank you. Yeah, so I mean, essentially, as introduced, the program is there to help businesses to explore and adopt digital technology. And of course, we've been talking about additive this morning. And as Claire mentioned, really the start point would be for any business that's interested in SMEs across the Northwest, just to register. First of all, on our website is quite straightforward. We will actually respond as quickly as we possibly can. We'll have an initial visit. We'll discuss what your key issues might be and your needs, and we'll take it forward from there. And really, there's 4 key ways that Made Smarter can support, and that is, we've talked about quite a lot today about the advice and guidance. That is all fully funded from technology specialists and from my own team. And then we can then take that forward where relevant. The business can be supported with grant funding for the adoption of that technology. And you can just come to me and I'll talk to you more about what that might involve. Another area we can support is by what we call digital technology internships, and that is providing specialists to come and work fully funded on a short-term basis, up to 3 months, and that is fully funded by Made Smarter, and that is to help businesses with R&D or adoption or implementation of any particular digital technology project. And finally, we also have a leadership program that is part funded by Made Smarter. A business needs to invest in that, and that is run as on a cohort basis in partnership with the Lancaster University Management School. And we've now run probably around about 5 cohorts during the Made Smarter program. There is an opportunity for businesses to continue to work with us now for a further 12 months until the end of March 2022. There's further announcements due about the wider benefits and impacts of Made Smarter going forward. We are waiting for a further announcement before we can pass that on to eligible businesses. But in a largest nutshell, that is us, and that's what we're there to try and do. So please feel free to register or email either of us, and we can start taking things forward from there. Thank you very much.
Brilliant, Ian, thanks. Just before you go, I've had a question on the chat from Neil. Can startups come on board on Made Smarter?
Yeah, the startups, that will be an area depending on where they're at. So if a business fundamentally has already invested, they are technically trading, so they've invested in the setup of the business and they're ready to start moving forward, then yes. but generally not if they're not in a position to trade or haven't invested so far in the business. Hope that helps, Neil.
Okay, Ian, thank you so much, Ian. Yes, I'd just like to talk now briefly about how Lancaster University can help you. As both Alan and Andrew mentioned, the GISMO project can provide fully funded support to businesses that are in Cheshire and Warrington. But if you're from further afield and you think you'd like to talk to Lancaster, please do come and talk to us, because there are all sorts of ways that we can help. And that's whether you're investigating the technique for the first time, perhaps you're establishing your own in-house capabilities, or perhaps you've got existing capabilities that you're looking to expand. So we can help whether you're proving a new concept design, product or process, or you've got a problem that or some materials issues that you'd like to address. And we can also help you, as we've done to a certain degree today, I think, understand some of the latest thinking and techniques. So if you'd like to get in touch with the GISMO project at Lancaster, here are the ways to do so. You can get in touch with us at gizmo@lancaster.ac.uk. If you'd like to follow us on social media, you can look to both Twitter and LinkedIn to do so. Now, during the panel discussion, I think it was Andrew that mentioned, when he was talking about developments in the technologies, the new materials, and one thing in particular that we'll be addressing in our next GISMO seminar on the 26th of March is new alloys in additive manufacturing, when our colleague Professor Pedro Rivera will be speaking. And if you'd like to attend that event, you can see the link there in front of you. Please do book on, and we'll be really pleased to see you. However, that brings us pretty much to the end of proceedings today. If you have any questions, do put them into the chat, or email us at GISMO, and we'll look to respond to them. But again, I'd just like to say thank you so much to Mark Bowen for chairing the panel session, and to Claire, Ian, Andrew and Alan for attending, but also to you for taking part and for listening in. We hope you enjoyed it, and we hope you've taken a lot from it. And thank you so much for coming along and listening and watching, and hope you have the rest of a good day. Goodbye now.